Okay, let's see, what does this problem read? Let's say the Sun orbits the Milky Way galaxy once each uh, in 260 million years, with a roughly circular orbit averaging a radius of um, 30,000 light years. Um, Calculate the centripetal acceleration of the Sun in its galactic orbit. Does your result support the a nearly contention that a nearly inertial frame of reference can be located at the Sun? Okay, so again, the Sun is part of the Milky Way galaxy, and it turns out that the Sun is roughly somewhere there, and its orbital radius is 30 light years, or 30,000 light years. Okay, and what is it that we're trying to find? The period is given to be 260 million years. Period is 260 million years. And we want to calculate the centripetal acceleration. Okay, so the centripetal acceleration is v squared by r. Well, what we're given is the period, so, and the period is 2 pi r over v, so v is v square is 2 pi r, oops, v is 2 pi r over period 4 pi square r square over t square. Okay, and we're going to put that in the centripetal acceleration formula. But before we do that, we need to add a page. Okay, here we go. So the centripetal acceleration in terms of the period is v squared by r, and v square is equal to 4 pi square r square t square. Divided by r. So the centripetal acceleration is 4 pi square r divided by t square. Okay, let's put in the numbers. 4 pi square, r is 30,000 light years. Yep, 3 times 10 to the power 4 light years. And in one of the previous problems, we calculated the light year in meters. I'll write it here. Light year, and 9.46 into 10 to the power 15 meters. That's 1 light year. Okay, so there is the conversion factor. Divided by t squared, 260 million years. 260 into 10 to the power 6 years. Now each year has 365 days, each day is 24 hours, 3,600 seconds. Okay, this has to be squared. Okay, so let's do this. 4 pi square. Let's take care of the powers of 10. 3 times 9.46 into 10 to the power 19 in the numerator. And the units, as you can see, are meters per second square. It's an acceleration. Okay. In the denominator, we have this is we'll borrow 10 to the 2 from here, so we'll make that 2.6. 10 to the 2, 10 to the 8, 10 to the 10, 10 to the 11, and 10 to the 4 plus 3, 10 to the 14. Okay, again, 3, 4, 6, 12, 14. Okay, so the denominator is 2.6 into 3.65 into 2.4 into 3.6 square, and 10 to the power of 14 square is 10 to the 28. Okay. All right, so you can already see that the acceleration is going to be tiny. Okay, and an inertial frame is a frame of reference that's non-accelerating, and so the acceleration of the sun as it travels around the galaxy is essentially zero. So it will be, you can see that it can easily be considered an inertial frame. Okay, so let's take care of this. So let me do that. Square this inverse into 4. Okay, so this works out too. Okay, I'll write it here. And so the centripetal acceleration works out to 1.67 times. This was what did we say? 10 to the minus. Oops, I'll write it then. Actually, so it works out to 0.167 into, and this is minus 28, so minus 9 into 10 to the minus 9 meters per second squared. A very small acceleration, and so we can consider the sun frame attached to the sun as an inertial frame of reference. Okay, calculate the average speed of the sun in its galactic orbit. Okay, so now we'll calculate the orbital speed. The orbital speed is 2 pi r divided by the period. Okay. And we have those numbers. 2 pi r is 30,000 light years. And each light year is 9.46 into 10 to the power 15 meters. And the period is 260 million years. Oops. Years. And each year is 365 days, 24 hours, 3,600 seconds. Okay, so we've done this several times, but anyway. So the velocity, okay. Again, let's take care of the powers of 10 first. So this is 10 to the 4, 10 to the 5, that's 10 to the 19 at the top. So 2 pi into 3 into 9.46 into 10 to the 19, and the velocity will work out in meters per second. And in the denominator, okay, so let's gather powers of 10. And 2 from here, 2 plus 6 is 8, 8 plus 2 is 10, 10, 11, 11 and 3 is 14. Okay, so 10 to the 14, and this is 2.6 into 3.65 into 2.4 into 3.6. Okay. All right, so let's add another page below. Okay, and what does this work out to? So that's 10 to the power 5. 10, 19 minus 14 is 5. Okay, so let me calculate this number here on a calculator. So 2 into pi into 3 into 9.46 is equal to, divided by 2.6 into 3.65 into 2.4 into 3.6. Okay, so this works out to 2.17 times 10 to the power 5 meters per second. Okay, so velocity works out to 2.17 into 10 to the power 5 meters per second. This is equal to 217 into 10 to the power 3 meters per second, and that's 217 kilometers a second. So that's the speed of the sun as it orbits around the galaxy. That's the orbital velocity of the sun. And I think that takes care of that. Okay. Compare this to the orbital velocity of the Earth, which is 30 kilometers a second. Okay. So the sun is traveling 7 times faster around the galaxy. Okay.